Earlier, the adjectival term hominin refers to the tribe Hominini. By recent convention, the term hominin refers specifically to humans and our extinct bipedal relatives. The term hominin is applied to Homo, Australopithecus, Ardipithecus, and others that arose after the split from the line that led to chimpanzees. That is, fossil members on the human side of the split as hominins.
So, let's break down what that technical definition really means. In this explainer, we're going on a journey way back in time. First, we'll get a clear definition for hominin. Then, we'll look at our starting point, that primitive ape baseline we inherited. After that, we'll explore the one single trait that changed everything, dig into the incredible ways our anatomy was rebuilt from the ground up, and finally, see how these changes set us on the unique evolutionary path that resulted in, well, us.
Alright, to really get into our story, we first have to be absolutely clear on what that term hominin actually defines. It's the key to the whole thing.
You see, the really crucial point here is the specificity. Hominin isn't just some vague term for an early human. It actually pinpoints a very specific moment in time. It refers to every single species on our side of the family tree after that big evolutionary split from the lineage that led to modern chimpanzees and bonobos. So, if a fossil is found on the human side of that Great Divide, it is, by definition, a hominin.
Now, before our lineage took its own unique path, our ancestors shared a common body plan with all the other great apes. To really appreciate the massive changes that made us hominins, we first have to understand this anatomical starting point, our primitive baseline.
So this is the blueprint we inherited. It's a body perfectly engineered for a life up in the trees. Think about it, an upright trunk, a wide rib cage, and these shoulders and wrists with an incredible range of motion. That's the suspensory hanging adaptation in action. The long arms were for reaching out to the next branch, and the long curved bones in the hands and feet were for getting a solid grip.
Okay, with that ape baseline established, we can now turn to the one pivotal change that created an entirely new branch on the primate family tree. This is the single trait that defines every last hominin.
And there it is, terrestrial bipedalism. It's the commitment to walking on two legs on the ground. This isn't just one trait among many. It's the foundational adaptation for our entire lineage. You could say every other major change that we're about to see stems directly from this fundamental shift in how we moved.
The driving force behind such a drastic change was the world itself. Africa's climate was shifting. Those dense forests began to shrink and break apart, creating smaller patches of trees separated by wide-open grasslands. Walking on two legs turned out to be a highly efficient way to travel between these scattered resources. It literally opened up a whole new world of possibilities for our earliest ancestors.
But here's the thing, becoming an efficient biped wasn't just some simple tweak. It demanded a complete overhaul of that ancestral ape skeleton. It was a total re-engineering of the body, from the head all the way down to the toes.
Let's start from the ground up. The transformation of the foot is just dramatic. It went from being a flexible, almost hand-like tool for grasping branches, you can see that opposable big toe on the ape foot, perfect for climbing, into a rigid platform. The hominin foot developed a strong, aligned big toe for pushing off the ground, and a brand new system of 3 arches that act like shock absorbers with every single step.
And right at the body's core, the change was just as profound. The tall, narrow ape pelvis, which was built for moving on all fours, got completely reshaped. It became short, broad, and bowl-shaped. This new design provided a stable base of support for the entire upper body, and it repositioned the powerful gluteal muscles to stabilize the torso while striding, instead of just pulling the leg backward.
And 3 other crucial changes really sealed the deal for this new way of walking. Our spine went from a simple C shape to a complex S curve, which acts like a spring to absorb shock and perfectly center our torso's weight. Our thigh bones, the femurs, started to angle inward, creating what's known as a valgus knee. This clever angle places our feet directly underneath our center of gravity, which stops us from waddling side to side. And finally, the foramen magnum, that's the opening for the spinal cord, it actually migrated from the back to the very base of the skull. This let our head balance effortlessly right on top of our spine.
So, once bipedalism was established, it really set the stage for a whole series of other profound evolutionary trends. These divergences in diet, in brain power, and in behavior are what further separated hominins from our ape relatives.
One of the first things to change was the teeth. You see, apes have something called a honing complex, these large, sharp canines that are constantly sharpened against the first lower premolar. Hominins lost this. Our canines became much smaller, and that premolar developed two cusps, becoming bicuspid. This new dental arrangement allowed for much more effective grinding and chewing, which points to a major shift toward a more varied diet.
And right here, we see one of the most significant trends in our entire lineage, encephalization. That's the increase in brain size relative to body size. From an early hominin like Australopithecus afarensis to an early member of our own genus, Homo habilis, the trend is unmistakable. And of course, it all culminates in the astonishingly large and complex brain of Homo sapiens.
This expanding brain power goes hand in hand with another major leap, the invention of stone tools. The earliest technology we know of, the Oldowan tradition, involved creating simple but incredibly effective choppers and razor-sharp flakes. This wasn't just tool use, this was tool manufacture, a massive cognitive breakthrough that unlocked entirely new food sources, like the calorie-rich marrow hidden deep inside scavenged bones.
The shift to terrestrial bipedalism demanded radical anatomical reorganization from the Great Ape ancestor, which possessed an upright trunk posture and a short, shallow, and wide rib cage, but retained long arms and short legs. In the next video, we will briefly discuss 5 groups which represent successive adaptations to changing African environments, particularly the shift from forested habitats to more open, arid grassland savanna.